what we'll do is I'll finish timed invalidation from chapter 15, jump into 16, which is escaping the graph. And then we'll see if we can start doing 17. I really think 17 is just kind of a broad overview of like, these are the topics that we're going to cover in like 18, 19, up to 25 and or up to 24. So 17 shouldn't take too long, but let's just kind of dive in and start talking about it. Again, if you have any questions or any comments or want to add anything, please do. Don't be afraid to stop me at any time. Especially when it got to escaping the graph. I think I did pretty well grasping the concepts. I did have a couple questions, and so please jump in if I do say anything wrong, or if you need to add anything, please do, because I'm still a little shaky on that one. So well, let's talk a little bit about timed invalidation briefly. I'm going to share my screen. Let's share desktop 2. So can you guys see my slides? Okay, cool. So where we left off, we were talking about isolating code, but then we started talking about timed invalidation. And so timed invalidation is really focused on getting or having tools that allow you to invalidate the graph based on a dependency of time. And so what it does is it allows you to use different functions like reactive timer to, in the background, invalidate the graph at a certain amount of time so that it goes through that validation flow again. And so it did a couple of examples in the book. This one where it was trying to do a frequency, or it created its own function to do its own plot, but it was trying to create a different plot of a different distribution based on different inputs. But what it was doing is that it was using this reactive timer to invalidate the graph so that it would continually update that distribution with new numbers or with new values. And so that's what this one was doing. But it also talked about some helper functions too. There was this discussion about invalidate later, which allows you to invalidate a node in the graph based on a certain amount of time. It's the same thing as it was with reactive timer, but it allows you to do things like in an observe function to do this. And it talked about why you might want to do this. And I won't dig too much into it because it made some sense to me, but it was kind of hard to create an example. But it was talking about using this invalidate later to ping and see if like your data has changed. So you use this observe function, and what you do is you have like some like read CSV or even a SQL query that, to query into a database to do like a check, like every so often to say, hey, has the data changed? Hey, has the data changed? And if it has changed, then it would go through that invalidation flow, changing the input, invalidating the validation flow, and then rerunning the graph. I thought that was kind of cool. I was trying to think of a way to create an example of that, but again, it's based on being able to like ping your data outside of the application. Well, I guess it could be in your application too, but pinging the data to see has it changed, and if it's changed, to invalidate the graph and then go through the validation flow again. And then it also talked about some additional tools to do that. It talked about reactive poll and reactive file finder. Those were just some helper functions that, if I remember correctly, it would look at like the modified date. It wouldn't look at the underlying, reactive poll would look at the underlying data, but reactive file reader, I think, was looking at the metadata associated with the file. But somebody correct me if I'm wrong. It's been a while since I've read the chapter. But the big picture of it is it allows you to ping the data, see if it's changed. If it has, it invalidates the graph and goes through the invalidation flow. So what questions do people have about timed invalidation?
I was only going to add a comment towards I think this is where a lot of our weight, I don't what do you call those widgets, the little spinners and the graph progress and that kind of stuff. Like you're looking, or you're giving the application time to refresh, or the server side time to refresh whenever you make a call to change the data. I'm thinking of like Netflix or any of the websites that you try to buffer or change things. If the data that you're connecting to is constantly at a fluctuation point, you want to make sure that you're providing the sync. Your browser and your server are in sync with each other, so that the media is updated as well. If you are connecting to a poor network, or I don't know, your server is calling from that database that you were mentioning, if there is some latency involved in timing, you want to be able to gracefully shut down your browser calls so that you're not just spinning your wheels and going nowhere. Kevin, do you run into this at all with any of your services, or are they within the same infrastructure? Okay.
Nope. I'm having a hard time imagining the use case, like Collin was talking about. Just like I don't know in what context to use these tools yet.
Well, the one thought that I came to mind was, just network latency in general, right? So if your browser is making this call and you're on a, I don't know, 14K modem, that's not appropriate, but I'm saying a really slow connection, you make the call and then you're just spinning, waiting for it to update. I think this is on the server side, if I'm not mistaken. The shutdown or the termination of that output is probably on the server side. That the second component I was going to add or comment on is the not lineage, what's the word I'm looking for? The age of the hardware. So if you're running on a really old server and you're just spinning up resources to try and output some large quantity, and it's just, grinding to a halt, you don't want to give up on the website. So let's go ahead and terminate that thread and continue on with other activities without spending exhaustive resources on trying to render the plot.
Going back to what Kevin said, thinking about use case, and if I'm understanding where you're coming from, Kevin, is I was thinking about it like, say you had like some AWS bucket or some like GCP bucket, like just like a bucket in the cloud where you had some like system that would push like a CSV file, like say it just updates every so often. What you could do is you could connect your application to that like GCP bucket or AWS bucket, and it would just like ping it. It would be like, it would ping it out and say like, oh, has the data changed? Oh, if it hasn't, then don't do anything. And if it has, then invalidate the graph, run it again, and then now you have that new data. And so I actually, when I was reading this, I was like, this sounds like what Kevin does, because I think you manually update data, correct? So that's what I was thinking, was like, oh, go ahead. Sorry.
I was going to say, I do it manually still. So like I'll just download data from Qualtrics and then just download it. I mean, it's pretty easy. It takes 15 minutes in the morning, just boop, and then test it before it pushes out to mshiny02, and then move on with my day, make sure there's no issues. So
yeah, I mean, if you wanted to automate it, you sure could.
I know, I'm still nervous about doing it. I'm still to that point. I would like to see it before it goes out to the client. So I'm still a little bit of control.
Yeah, and that's kind of getting in the realm of like data engineering rather than like analysis and like front end stuff. And so, but I mean, the capabilities there, like I was thinking about it, I was just like, wow, that's really cool, because you could essentially have an application that would ping it out and say like, has the data changed? And if it has, then invalidate the graph and so on and so forth. So I thought it was pretty useful. I thought it was interesting.
I may want to build a toy with that though first before I implement it. So that seems like a fun project.
Yeah, and I mean, like, and two, it's the biggest struggle that I've found, and granted, I haven't done connections into like a GCP bucket or an AWS bucket, but the biggest the biggest hurdle is just like the authentication portion of it. Like setting up, how are you going to authenticate into that service has always been like a struggle. And I mostly work with GCP, like Google Cloud. That's just always been like, how are you going to authenticate? Because it's not you that's authenticating into it, it's an application. And so, but I thought it was pretty useful. I thought it was kind of interesting. Cool. Go ahead.
I was just real quick. I was going to say, I was reading a lot about that because I was trying to get my head around GitHub Actions, and I got into a thread on SSH keys authenticating through GitHub Actions. I was like, oh, above my level for the time being.
And that's where I also thought too, is Actions was kind of a cool thing that I've been kind of looking at too. But yeah, I mean, that again, that's getting into like more like DevOps and data engineering and just stuff that's above what I know how to do. I mean, I know enough to be dangerous, but I would not consider myself to be a DevOps person. So cool. Well, that's 15. Tonight, what we're going to discuss is chapter 16, which is escaping the graph. And so the learning objectives for this chapter, I'm bump up this text so we can see it a little bit better. The first learning objective was to learn how to escape the constraints of the reactive graph and really trying to understand how we can actually escape the reactive graph and how we can escape these constraints that are put on us by the graph. And it really also talks about trying to observe techniques to combine and connect a reactive graph by applying manual controls over the parts of the graph. And so there's several situations or several kind of case studies that this chapter kind of talks about where you might want to find ways to escape those constraints that are applied by the reactive graph. So the way I kind of think about it is, giving you, the app writer, the flexibility to invalidate the graph and not necessarily invalidating the graph based on a user input. And so being able to build the functionality within your application that has like a certain logic in it, that if something happens, how you wrote it can invalidate the graph rather than what the user input is. And so those learning objectives. So the questions being answered in these notes are, getting a better understanding of what's happening inside of the application, really trying to figure out how we can escape those constraints of the reactive graph, and really trying to answer questions about how we can use reactive value and observe an observe event to apply that manual control over parts of the graph. And so since it's been a while, I think it's a good idea to just do a quick recap or a quick review of what reactivity is. And so just big broad strokes, reactive programming is used to specify those graph of dependencies so that when an input changes, all the related outputs are automatically updated. And so we spent a lot of time, I think probably 3 weeks now, going over the different building blocks and then how the actual how Shiny goes about using those different components of the graph and how it makes connections and what's the flow it goes through to make those connections to get a validated graph. And that process of reactivity is meant to only use the resources that it needs. And so reactivity is a lazy process. It only computes what it needs to, or it tries to only do the least amount of work as possible. And so again, the reactive graph describes how inputs and outputs are connected. It's that powerful tool that helps us understand how the app works. And it's useful to help us sketch out those dependencies in your graph. And in fact, tonight, I'm going to lean a lot on the React log package to kind of see how we can kind of break out of that, the reactivity constraints that are created. The reactive program framework is useful because it automatically determines the minimal amount of work or computations needed to validate the reactive graph. So Shiny will do the heavy lifting for us. This is especially important within this context of this chapter because us escaping out of the graph could result in us setting up some type of flow that's going to require us to use a lot more computational resources than are needed. So it's just good to kind of know that there's times where we need to escape the graph, and then there's times where we should lean on the ability of Shiny to automatically calculate how many resources are needed to validate the graph. But as the chapter discusses, there are certain situations where we need to actually escape the constraints of reactive programming. And so there's 3 or 4 case studies that we're going to go through that talk about that. So where might we need to do this? So we might need to escape the graph when we're trying to control or manually modify an input. And so we'll talk about a case study where I think it's called the Salutation app, where we have some functionality that allows us to clear out a specific input, which then invalidates the graph. But that control only happens if we manually set it up to escape the constraints of reactive programming. Situations where we have one output that is influenced by multiple inputs. And then also in situations where we're trying to pause animations or computations. And so the thing about this is that, yes, we have the flexibility to do this, but this is also a very dangerous thing that we could be doing in our application. This flexibility is powerful, but be careful, because for one, like we mentioned before, it can cause unnecessary computation to be performed. And then lo and behold, our friend infinite loops comes back into play here, that if you are not, if you create certain dependencies within your server function, you could create an infinite loop. And so we've seen a couple of examples of that. We'll see an example of it again tonight. So it's a trade-off. You get the flexibility, but there's some situations where it can be dangerous. So this was left over from the previous cohort. They tried to kind of create a diagram of what this looks like for the general application. I had a little trouble understanding. I didn't go back to the old recording, which I probably should have. But if this graph helps you kind of better understand it, it's available for you to kind of review. So the first thing that we're going to talk about is this process of combining reactive values. So in this first part, we learn how to combine reactive values, which are escaping the graph. And we're going to do this to modify the value of a reactive value. We're going to use either reactive val or reactive value functions. And then we're going to combine that with the use of observe and observe event in the server. And so what we're going to try and do is we're going to try and cause invalidation that's not being captured within the reactivity or within the reactive graph. And so this process is going to be escaping the graph, and it's going to give us manual control to help us invalidate the actual, to invalidate the graph based on certain actions that happen within the application. And so I think the best way to kind of talk about this is looking at the specific example. So I'm going to run this example here. This one is in the book. This is just from the, this is just the example from the book, but it's the Salutation app, or it's the Salutation application. Real simple. All we really do is we have a text input where the user gives us their name. We have an action button, which allows us to clear that. And then another output, which is the salutation. We have a reactive function here, which is going to create this reactive, which is just putting together 2 string values, the hello, and then the input name, and then the render text. But what we're going to do is, to escape the graph, we're going to use this observe event function here, which is based on this input, which is the action button of clear. And what this is going to allow us to do is it's going to allow us to manually change that value of input name back to 0 length string. And so let's just watch it in action here. Let me jump over to my R session. Backlog. Okay, so here's the application, real simple app. Let's just say I enter my name. Here's the output. And so what I'm doing here is I can just clear it out. And then again, it just clears out my input. I'm just going to enter another name for the heck of it. Clear. Let's do another name, Cindy. Clear. And then if we open up the reactive log to look at this, we can see how this application actually works to how we can use or how we can escape the graph by using that observe event. So if we watch how the flow actually works, here I'm entering my name, it invalidates the input. So then it's going to clear out, or it's going to invalidate the graph. So then it's going to rerun the salutation, create those connections, and then pull that string value of Collin all the way through. Now, once I hit the clear input, what it's going to do is it's going to change that observe event, which is based on the input clear. And as a result of that, it's going to invalidate that observe event, create this connection between input again, which is going to be the clear event. And then it's going to invalidate the input here, changing it back to that 0 length string. Here we're in an invalidated state. And so it runs through and invalidates our reactive expression, our output. And so it goes through again to revalidate it. And because our input has been changed to the 0 length string, it will be a 0 length string again. So what questions? I know I went through a lot there. So what questions do people have about this step-by-step flow of how we can use this observe event to break out of the reactive constraints of the graph? Or was it all? Oh, go ahead, Ryan.
No, I was just going to say, I don't think it's a question so much as we're establishing a thread to the server for the variable character or the name, right? So we're passing the name back to the server so that it prints out, correct? And so by hitting the clear button, we're severing that particular thread, which resets the variable back to 0 again and waits for another input. I think I may just be repeating myself, but I think I understand the reactive call or the clear button as being, I've entered the data, I'm still leaving this door open. When I hit the clear button, it's like shutting the door so that I can open the door again. I'm probably just reiterating myself again. I think I understand how this call is happening or this particular text is happening.
Mm-hmm. I think the big thing to recognize about this with this observe event, it's not creating a dependency based on an input. Well, it is, because this technically isn't an output because this is an observer. So how can I explain it?
Well, the browser's sending the name back to the server. The server is sending back the finished string of hello, whatever you entered. By hitting the clear button, it's severing that reactive call and then I guess resetting it. It's putting it back to sanitized state. It's going back to that 0 state so that it allows us to enter another call again. And I think the process of this recording is just watching that passing of information from client to server.
Yeah, pretty much. I mean, it's just invalidating it. Like it's giving you that ability to invalidate it so you can do another call into it, right? I think that's if I'm on the same page as you.
It is. Well, it's that I'm probably confusing it with how the client is making the connection to the server, passing the variable back. Server replies and says, here's the concatenated string of hello, and then whatever the name you passed. By hitting the clear button, you're truncating, deleting, resetting, whatever term you want to use, that particular point back to 0, or actually you're completely severing the call all over again and then reestablishing a new connection.
Mm-hmm. And that invalidation happens with the observer. So the observer is invalidating. It's not the input that's invalidating it here, it's the observer. Like, yes, you do have an input of clear here, but the invalidation step is happening from the observer because it changes this input name, correct? Is that what I'm thinking? Input name.
Yeah, that makes
right.
sense. That makes sense.
Because it's changing the input name. So it's not invalidating the graph based on the input, it's invalidating the graph based on what this observer is returning, which is the update text input. So I think that's kind of the important concept of it. Any other questions, comments? Like I said, some of the stuff is like, it looks very simple on its face, but then when you start kind of digging into it, you're like, well, how does this affect? Because again, it goes back to the reactive graph. How does this affect the reactive graph? And so it kind of goes against some of the rules that we were talking about back in like 13, 14, and 15, because now it gives you more control to invalidate the graph, not based on inputs, but on observers and reactives, if I'm saying that right.
Thinking like not shiny related, but let's say I'm trying to, I don't know, buffer a YouTube stream, right? And so your browser makes a call to the YouTube server. The server is processing that media and sending it back to you. When you either close the browser or say, you know what, give up, just hit the stop button on your browser, that's almost like that kind of clear button where it's saying, I don't want that media anymore. Stop spending the resources to generate it. It's severing the call of the server processing that output again, resetting it ultimately.
Mm-hmm.
Have you ever been on a poor server and you hit the stop button and then try to refresh it again to see maybe if you can get a different I don't know, a different network path to get the media to process a little bit faster? Sometimes you'll connect to a server, web server, whatever it may be, and the first initial call is not working as intended. You hit the stop button, you hit refresh or clear your browser and start over again. That's a different process. But by stopping the server, by stopping that browser to server handshake, the server's receiving that point or the connection, the clear button is sending the call back saying, I don't need this information, reallocate the resources to process or stage again for a new awaiting input.
Oh, yeah. I think that makes, yeah.
See where I'm going with the stop button concept?
Yeah, I'm following
Okay.
with you. I just don't know if I could put it into
Yeah.
clear enough words, but I'm following with you of like, it's invalidating it. So it's like waiting for another input, but it's going to pass that input again to validate the graph.
I'm seeing this, the stop feature of a browser and the refresh feature of a browser as kind of this similar reactive call or the clear button that you're using within this particular snippet of code.
Mm-hmm. Yeah, I'm following
Okay.
you. I just don't know how to put it into words.
Yeah. Okay.
Again, that's one of those things like where you see it. Like I think the best thing was that kind of clarified it for me was like just opening up a React log and watching it like go through the process and seeing how it actually invalidates. Like you really have to have a strong understanding of the validation flow. So going back to like the reactive building blocks and remembering how the graph goes through validating, because this is saying, well, just so you know, you have tools now using observers to change that validation flow, so you can escape the graph. Again, the previous cohort had this graph. If this is helpful, kind of look through it. Again, I think for me, the way that I kind of understood it a lot better was to kind of look at the reactive log, just kind of play with it, put the inputs in and see how it changes. But here's another resource to kind of help you kind of understand that flow. This was kind of left over from the previous cohort, but connecting the right side with the left side. So here's another diagram for you kind of talking about this, really talking about how we combine reactive values in the observe event to change inputs from the UI to, again, invalidate the graph. So it goes through that validation process again. Where I think the chapter was kind of the meat of the chapter was kind of in the case studies. Well, I think the most practical parts were the case studies. And so with this, I'll just kind of go through the case studies and look at each example. But the book kind of talked about where you might want to escape the graph is in situations where you have one output that is modified by multiple inputs. And so the first example that it shared with us was just this very simple application that gives our user two action buttons, a drink action button and an eat action button. And what gets returned from these actions is this text output, which is our notice. So it will just say either drink me or eat me, and I'll share with you in a second. But what it was doing here is that technically we have two inputs that are trying to modify one output. And so we have to escape the graph to accomplish this task. And so here we start with reactive values with the notice. And the reason why we're using this reactive values notice equals this string of length 0 is because at the initial startup of our application, we don't want anything to be shown to our users. However, once our user clicks either the drink or the eat button, we use the observe event to watch for each input. And those inputs are going to modify the notice in our reactive values object. And I kind of thought of this like a list or like, and I don't know if this is the right way to think of it, but this was just in my mental model, was this idea that we're kind of like creating a list. Again, if anybody's out there, you can tweet at me and tell me that I'm wrong. But in my mental model, it's like, this is like a list, which we're calling R. There's one value in here, notice. And based on these observe events of what's happening in the UI, we're changing that notice to either this string here or this string here. And as a result of changing that, our render text is going to render whatever's in that. And again, I'm going to use it for the lack of a better term, that kind of list object right here of our notice. And that's what gets outputted. Anybody agree, disagree, comments? I think we can watch it in action here. So I'm going to pass it in here to watch it. React log. So simple application, drink me. Here's our two inputs. These two inputs are modifying our one output. You can see changing to thirsty, hungry, thirsty, hungry. And then if we look at the React log, we can see that we have these two observe events, one output, and we can watch how the invalidation flow actually occurs. So the user hits the drink button. It changes this observe event, which is going to change the input drink or invalidate the input drink. The connection is going to be redrawn. And so then it's going to change input drink, go into our observe of the output notice, and then it's going to pull that value that's being changed in the observe event, which is either hungry or thirsty. So it invalidates, pulls it through, and it changes, and then it's in a valid state. Again, when our user hits the button again, it invalidates that input for eat. The observer sees that, it's going to invalidate. So then it's going to invalidate input eat, which is then it's going to look for the reactive value that we're changing. And then it's going to change that output notice, input or output, and then it's going to go through and then do again, change for eating. I think I did an okay job of explaining that. It might be kind of unclear, but what questions do people have about this case study right here using two inputs to modify one output? No way I explained that in a clear way.
I'm going to leave it as is. I've got a mental model in my mind here of a parallel circuit with two switches, changing the color of the light bulb in the hallway. So depending on if both switches are open or both switches are closed, it's going to change the color of the light. But if one person flips it on or off, it's going to change it as well. There was a tool that we used in training that showed how you can control the it's not the bit rate, but the output of this particular circuit depending on the points of the switch. And there's two switches, either on or off, but I'm comparing that same level of logic in a network call or a server client handshake in setting up this same reactive value of what exactly you're going to present and then possibly reset to start for the next input again. I'm getting a real clear connection on how this is actually occurring on the network end or the client server handshake end.
Mm-hmm. Yeah, and I mean, I think the big thing that the book was discussing is like, you know, you got to start off with reactive values, you know, setting it as an empty or a string of length 0, and then you can use these observe events to modify the output or modify the values within reactive values, and then you use that reactive values in your rendered text to change it, right? And then so when you change, like when the user clicks a certain button, these observe events are watching and change or like listening for that kind of change, right? They're listening for that change. And when that change happens, then it changes that reactive values and you got that switching back and forth. Did I do a lot better job of explaining it now? Like, I think you could see it, like when you see it, it makes sense. But then when I try and explain it out loud, it kind of like, it just kind of goes against, like, it just becomes kind of mud sometimes. But, so there's a more complex example with this. It talks about trying to increase or decrease a number. And so what this is talking about is, example, this going big picture of this being that we have 2 inputs modifying 1 output. But in our case, what we want to do is we want to increase a number or decrease the number of that value. And so what we have here is we obviously start with reactive values again. We have n0. But in our case right here, what we're doing is in our observe events, we're capturing that Rn. And so based on what the user provides for us, the input, up or down, it's going to either increase that value or decrease that value and then reassign it here in our reactive values object. And then it gets rendered in our rendered text. So I can run this example here so we can see it. If anybody remembers, so you remember like way back in like chapter 3, was it chapter 3 where they were trying to show us how to like, or one of the exercises was to be like, change the injury or like cycle through the injury. This helps you get there. This actually helps you get there to actually like increase the buttons and go through it. Let's see here. So here's the example, down, up. So it just changes this value here in our output. But again, the only way that this works is for those observers to pick up on those actions that are occurring and to change that reactive value. And then we can show the reactive log. So we can kind of walk through it here briefly, but then like the input invalidates, it's going to invalidate the observer. It's going to relook for that connection, establish that connection. And so because this value of Rn has changed, it's going to pull in that new, it's going to validate the graph by pulling in that new value of our reactive value that we have available to us. So it goes towards a reactive value, which is now -1. So to validate it, it's going to create that connection. I'll put n, validates, and it's going to revalidate it by pulling that output in again. So what questions do people have about this example here? So again, like how to solve that one problem at the beginning. I think from chapter 3, it walks you through, this is how to answer it. And in fact, if anybody's interested, I wrote a blog post about it a while ago. So if anybody wants to read how to do that solution, I borrowed the solution from the solutions guide, but I wrote a blog post about it because it was just bothering me how to figure it out. And so if anybody wants to read that, I'll be more than happy to pass it along. But this is how you answer that question, is with setting this reactive log 0 and then using the observe event based on the actual up and down.
So if you get a second, put it in the chat.
Yeah, let me pull it up. It's probably not my greatest work because it was like one of the first blog posts I've ever written. So, but it also requires the use of I think a modulus. So like, I think that's how it's pronounced, like modulus division or something.
Oh, yeah.
And I wouldn't, I take no claim for like solving this. I had to definitely look at the solution guide, but I provide a little bit more context of like trying to figure out like, how do you go about like, what does this mean? And what does this mean? But let me just pass along if anybody wants it. Put it in the chat here. I'm trying to get my blog rolling. So trying. Probably another reason why I didn't hold the session last time is because I was probably working on something for that. But yeah, you can read it if you want. But yeah, again, for that answer right here, this is how you get to that solution. Kind of similar. The arithmetic's a little bit different, but cool. So let's do this one. So this next one, accumulating inputs. It really kind of talked about this in situations where you want to like maybe collect data and like submit it. And so it kind of talked about like you might want to do this in situations where you're trying to collect data, like a form or something, like a form to submit. So what it's doing is it's giving us the ability to input names and then either delete those names or add those names. So we have 2 action buttons. We have the text input, the 2 action buttons, which are add or delete. And so add will be like adding it to our data source. In our case, we're just going to push it to the output, but then it allows us to delete that input, of text input. Again, to achieve this, we have to start off with reactive values being an empty character or an empty character vector. And then we use observe event to watch those inputs of input add or input delete. And then it just updates that text input. This was the second example from the book. It's the same functionality, but what it adds is it adds this union to make sure that we're not including any duplicates within our data. And so let's just take a look. Oh, it also uses the set diff as well in the second example, but let's just take a look at this. Okay. So here's our application, simple application. We can enter our name. Collin adds it, the add adds it to the output. And if we want to delete it, oh, excuse me, it deletes the input because it changes the input value. So like if I put John, I can delete the input here. And so that's based on the observer changing the input or manually invalidating that input, and then it changes the input here. But all this does is John add, let's do Tom add. If we look at the interactive or the React log, F3. And so again, this is getting a little bit more complex, but let's see, observe event. Here's our output names. And so if we run this, we add the value to it, which was my name. It changes that observe event, which is that input add. So then we're in a state of invalidation. So it's going to start going through to try and pull or to reestablish those connections for my inputs. Since it was an add, it's going to pull in my name. And then it's going to look at reactive values for the output. And it's going to output it as my name to the UI. Let's see if I can get to the delete state. So I think the next step was delete. So then I did an input name. So I added my character name to it. Or yeah, here's the delete state. So, so let's see. Yep. So then it cleared my input name. And then I hit delete, change that input. So it's going to change this observer here, which is then going to invalidate. And then it's going to look up John. John was my input. And so it should delete John once it validates again. Yep, it deleted John and validated that input, changed that input, and it goes through trying to go to a validated state again. Questions about this example here? Let me delete some of these dead tabs. Like I said, sometimes it's hard to put these in words and you really just have to kind of look at the graph, because I think the graph is the one that kind of tells you like how it's actually going through and invalidating, again, not based necessarily on user input, but on like the logic that we put into our application through the use of these observer functions or these observe events. So the next example was pausing animations, and so I gotta keep an eye on the time here. So this was another one looking at pausing animations. We have two action buttons, the start and stop. We have a simple text output, which is a number value. And so in our reactive vals, now what we have is we have two values. We have this running value, which is false at the initial state, which is false, and then an end value starting at 0. And so what we have is we have our observe event. So when we click the action button start, it's going to change the reactive value into true. And when that happens, then it's going to do running. So it's going to be looking for this running value in React vals. And since it's true, what it's going to do is it's going to add 1 to that value. And then as long as it's still true, it's going to change, or it's going to invalidate it's going to invalidate the graph every 250 milliseconds. And so it will continually add up as we go through it. Now, this is the, warning lights right here, is because in this situation, if we don't use isolate, what it's going to do is we're going to create an infinite loop. And so we have to make sure that we isolate this RN function here, or else it's going to be just stuck in an infinite loop, regardless if we hit start or stop on the application itself. But then it's going to keep adding up. It's going to keep invalidating every 250 milliseconds. And then it's going to change our render text, which is going to change the output in our UI. And so we can take a look at this one here. See. Stop, Control V. And so if we hit start, the animation actually starts. So we're going up. When we hit stop, it's going to stop. If we didn't have that isolate within it, within that application, it will continually keep going up because we're in an infinite loop. So this is a situation where we need to be careful when we're trying to escape the graph this way. But there's start or stop. Any questions about this one here? Yeah. Let's see. Loops. Oh, again, this is the warning that we were saying before, that this is a situation where if you don't use isolate with an observe, it's going to, it's going to create that reactive dependency that never stops. And so it's going to create that infinite loop and go on till infinity. But then, resources are limited. So if it gets high enough, you could crash your system. So anti-patterns. This is the last thing that I'll cover because I think this was kind of an interesting discussion. So with anti-patterns, this is another warning that the book was talking about, where you can use the observe, like, you can use the reactive functions and the observes, and then, obviously you have your render plots and your render tables. But the book really talks about that you can get into these situations where you can achieve the same functionality of the application by just using a simple reactive. And so it talks about that if you're doing it this way, what's going to happen, there's like several drawbacks for this. The first one being is if you're doing it this way with the reactive values and the observe, in certain situations, if you have plots or certain outputs hidden behind tabs, that observer is still going to create that output. And so it's still going to show up. And so if you're going to do something like this, it's better to just have it as a reactive rather than doing like the reactive vals observe, or else it's going to push it through the output. There's some other issues with error propagation. If you're using, and somebody correct me if I'm wrong, I'm trying to remember what the book was saying, but if you're using an observe function and there's an error, it's going to stop the application and it's not going to propagate the error to the UI. Somebody correct me if I'm wrong on that one.
You're talking about the drawbacks, correct? There's
Yes.
There's a second bullet here that says if the head throws an error, the observer will terminate the app, but the reactive will propagate. So it's displayed reactive thrown an error and it won't get propagated. Is that the comment you're looking for?
Yes, because I think what happens is if you're using this observer, it's going to kill the application on an error, right? If there was an error in like this call to head, rather that if you were doing it with a reactive, it's still going to push the error through to the UI and the application's still going to run. If I'm saying that correctly, right? Is that how you're reading it, Ryan?
The next paragraph starts off, and things will get progressively worse as the app gets more complicated. It's very easy to revert to the event-driven programming situation described in the event-driven programming on page 203. I think what they're doing is explaining exactly why this could become a more progressive issue. The further down the track you go.
Yeah, because doesn't it talk about like your focus, if you're programming this way with the reactive values and the observe, you're focusing more on the flow of events rather than trying to offload that work onto Shiny to create the graph for you. And it talks about that if you continually keep doing it this way, which your application will work, but you really want to try and offload that work onto Shiny to do what it does.
Yeah,
it automatically creates those connections for you.
Yeah, the last sentence says a simple graph is easier for humans to understand, and a simple graph is easier for Shiny to optimize.
Yep, and I put that in there because I thought that was kind of important.
Well,
go ahead.
Throughout all of the Shiny ecosystem, it's always about optimizing the handshake between server and client. No matter what you're doing, whatever code you're writing, whatever process you're rendering, it's always trying to keep everything as clear, concise, and simplified as possible. So you're not getting into this crazy overhead of just blowing up, amounts of text that you're not required to send and receive. There are tools and utilities to optimize the exchange of what Shiny's trying to apply.
I mean, the way I think about it, and I know we're at 7 o'clock, so if anybody has to jump off, feel free. I think it kind of goes back to that, like, just trust the theory, like, yeah, you have the capability to, define the graph manually, but, if you trust the theory, it will offload some of that, like, overhead, like you said. Yeah, like you said, like overhead of just remembering, like, okay, if this changes, this is going to change. If this change, if I have this manual change, this is going to change that input. But rather, I think the book was trying to get at of like, just make it simple. Let Shiny do what it's good at, take a step back and, you know, keep the graph simple, keep it simple because it's easier for you to understand and it optimizes what Shiny does well, which is, you know, it's reactivity. It's the laziness of the reactivity only processing what it needs to process. So, but
Well, there's a bridge I want to cross here, because when we're doing the EPGS cohort and talking about Collin Fay and all the document in reference to building or engineering Shiny apps, there is a rhetoric that is in every single chapter that says, keep it simple, don't overcomplicate things. You don't need C++, you don't need a bunch of extra code because even your developers aren't going to be able to help you. So always try to stay within the easiness of everything. And it's coming back out in this text as well, in this closure of 4 chapters worth of reactive calls. But I guess the second point that I was going to bring up was from the Monday's phone call with June. And when he was going down the rabbit hole, the ggplot, the under the hood type of, you know, hey, you can change these variables inside of what the calculation's doing kind of concept. I'm like, nobody's going to go that route. Not because I'm contesting with what June's showing us. I'm saying that if you are unfamiliar with what you're doing, just stay with what the process is. Don't try to optimize it. There's a reason why it's built this way. Yes, you have the capability, but just because you have the power doesn't mean you need to utilize it. And I guess that's kind of the rhetoric of most of these ending chapters or closure chapters, is saying that, yes, we're giving you the tools and resources to do this. Don't imply that you have to do it all the time. Does that help at all, or reinforce kind of what you're getting at?
100%. Yeah. I mean, I don't want to leave Kevin out if he has something to say.
No,
about
I'm
it,
sorry,
but,
Kevin.
No,
go ahead, Kevin. Sorry.
I was gonna say that's based on my skill level too. That's what I do. Is just keep it simple, keep it nice looking.
And I mean, I was kind of thinking about this too, of like, you know, going back to like when I first, and again, like I said, I know we're over 7 o'clock, so, you know, don't feel like you need to stay to listen to me pontificate about my experience, but like when I first got into like, you know, coding and like doing our stuff, and this is going way beyond broader strokes than like Shiny is like, oh, coding should be hard, it should be complicated, you know, this is computers, so we should make this as complicated as possible. And as I've kind of, and I'm going to say mature for the lack of better terms, or, you know, I've gotten more experience, it's like there are times that complexity is needed, but what you really should be focusing on is trying to make it understandable, because that's going to make it, you know, it's going to make it more robust. It's going to make it easier for others to work on. And I think that's kind of a good transition in the next chapter, because, you know, my mental model at the start was like, yeah, this should be super complex. This is computers. Like, we should be doing the most sophisticated, complex things. But like you said, Ryan, it's like, go back to, you know, keep things simple, because it's going to make your life a lot easier, and it's going to make others' lives easier, and it's going to make things better. And so, and I'm not trying to downgrade or bash anybody who, you know, who tries to make things complex, because there is a certain need at certain times for it, but simpler is better. So.
Many times you don't need the complexity. Sometimes it's just fun to try new things though, but kind of learn to keep it simple.
And I mean, like, going back to it, like another, and again, like, so anybody that's out there, I'm on the book tour for my blog, because I'm trying to get that going. But like, one thing that I've been trying to do with this is like create like summary tiles, like just basic summary tiles of like, you know, here's a metric for this specific day. And before, like when I was doing Shiny apps before I took this, it was like, okay, somebody's had to develop a package to do this, you know, and then you go out there and you try and find it, and it just adds more complexity to it. But like, 2 weeks ago, I was sitting there, I was like, let's just try and make a summary tile with what I have available. And, you know, you can do it, you know, and you can do it with what's just stock and Shiny to actually complete what you need to do. And so, I don't know, it just kind of goes back to that simplicity discussion of like, you're given the tools to do it, you know, you don't have to hack it sometimes. And so
I started working on an app, and I was trying to think maybe I won't do a dashboard, maybe I'll do an app. But then I really like the shiny dashboard components. And so I put in the CSS of shiny dashboard into this app. And like, I can do this, but I don't want to do this anymore. It's going to be a mess. So I just burned it down and started with a dashboard because that's what I wanted.
Mm-hmm. Yeah. So I don't know. And that might have been my own soapbox moment, but kind of going back, kind of semi-related.
I'm loving
Excuse
the self-promotion. No, that's awesome, Colin. You're doing great on the blog post. That's I'm gonna check out what else may have been posted up there so far.
Yeah, not very much. Most is just me just hammering on my keyboard, thinking I'm smart, but I'm really not. Half-baked ideas. Most of them are taken from other people, so I'm just trying to put it in my own words. So, but that's gonna be my next one. I think I'm gonna try and focus on those summary tile ones. But I mean, I can hang out for a little bit longer, but that's pretty much it for chapter 16. There's some other resource the book talks about, but I'm not going to dig into that. I think we can dive into 17 next week. And then if anybody wants to take 18, I'm more than happy for anybody to jump in on that one. So just let me know if anybody's available to take on 18.